So let's get started, everybody. Welcome to today's webinar. We got REScheck and IC3 features and 2021 IECC key updates. I'm going back through some of this because we still have a lot of cities that are recently adopting or have recently adopted the 2021. They've reached out with some questions and concerns when it concerns compliance with the code. So we're going to go through some of that stuff. Most of it, pretty much all of it, is Chapter 4. But we'll get started. As always, this webinar is being recorded. It's being uploaded to our YouTube channel shortly after. Yeah, you can find that by going to our website at Spear, or you can go directly to YouTube and look for our Spear channel. But I also put a QR code on the lower left-hand side. If you want to do a QR code, it'll take you directly to the link that'll take you directly to our channel for YouTube. There you'll find a lot of resources we've already done, videos we've already done, over 150 videos uploaded. Different topics that are there. It's listed by energy as well, so you can kind of narrow that down on what you need to look at. Today's webinar is eligible for the ICC CEUs. You must be present for at least 3/4 of the presentation. Within about 72 hours, you'll receive a course evaluation email from Kathy Lawrence. Please complete the survey, and that will contain the title and course ID that you'll need when she gives you the certificate. You'll have that with you, so you can use that for the reporting. As always, I've got the chat feature open. I've also got the Q&A feature open. Use either one of them to post any questions that you have. We'll either go through it as we are going through this webinar, or we'll wait to the end if it's something that's unrelated to what we're talking about. So let's get through this. So anybody that's new here, that's joining us for the first time, who is Spear? What do we do? So the SPEAR is an acronym for South Central Partnership for Energy Efficiency as a Resource. We're one of 6 REOs, Regional Energy Efficiency Organization, that is scattered throughout the United States. As you can see by this map, we cover Texas and Oklahoma. There are other REOs that cover a lot more states throughout the country. We are member-based. We're nonprofit. We're a 501c3. We have about 50 plus members, probably edging closer to 60 now. I need to update that. From a wide variety of energy efficiency industries, manufacturers, other nonprofits, other people that support us in the actions that we do. We're focused on outreach, education, collaboration on clean energy. So I'm here to help with any energy code questions. I can also address ASHRAE 90.1. I work a lot with building officials, third-party inspectors, architects, designers. They reach out to me with questions about how do we navigate through Texas and how do we navigate through Oklahoma. Even though both states are home ruled, they are different in how that they're structured and how other cities throughout their states adopt new energy codes. We've also helped with cities the adoption of the 2021. So if you're on the call today and you're looking to adopt the 21, or you're going through that process, by all means, feel free to reach out. My contact information will be at the end of this presentation. Feel free to reach out. I can help with meetings of council if we want to talk about and discuss what's important. I can help you guys with amendments, look at what other cities have done throughout Texas to lessen the impact of the adoption, especially when it pertains to your building department. So I wanted to bring this up. I don't usually put this on here, but I'll probably do it from going forward. We do on Spear's website have a city adoption list. So if anyone's interested in other cities around Texas about what code cycle that they're on, and also a direct link to their amendments, we do have that on our website. I did also add a QR code where you can just go directly to that. It's kind of a drill down. As you can see, it's under the incentives and then energy code, and then browse resources, and then compliance and adoption guide. So that's kind of a tough drill down. So I just went ahead and put a QR code. If you want to QR code that, and then you can save it in your favorites, you can look at that going forward. We actually update that. Kathy updates that about every 2 months. The things that are in yellow has changed in the last 12 months. So this helps if you're outside of Texas. Maybe you're joining us today and you're outside of Texas. You're a designer or an architect. And then you can look at this and go to our website and say, what city am I actually developing this project in? And then you can look at their amendments, or reach out to me. I'll do the research for their amendments, and we can talk about how it's different from just the written code. So Texas, as I said earlier, is unique. We have different pathways than other states. Some of it's been put in legislation for us from the House Bill 3215. We still have prescriptive. We had total UA alternative, which is a building shell, just trade-offs for windows and insulation values to reach compliance for the code. You have total building performance. We have the ERI, which is just a sliding index, a 2-digit sliding index that gives compliance for the code. We have Energy Star is also in the legislative words that says it also can supersede the code. Right now, currently, Texas is on 3.1. If a builder is doing Energy Star for the 45L tax credit, which we'll talk about a little bit later, in order to continue and get their tax credits, they're going to have, this is my understanding, if someone's on the call and they want to correct me if I'm wrong, but the house has to be completed prior to January 1st of 2025 to get that tax credit. If you have a project that's starting and it goes past and beyond that date, you'll have to already be on the 3.2 for compliance for your tax credits. That doesn't mean a city has to say that they're not compliant. That just means that if they're going to get tax credit, they're going to have to update it to the 3.2 to get that if it's going to go beyond the January 1st date. We also have RESnet HERS rating, which is technically same thing as ERI. And then we also have the North Central Texas COG, and we'll talk a little bit more about that a little bit later. So as you can see, we have way more compliance pathways through the code to be compliant than is just written in the book. So Texas gives that flexibility. As I just said a minute ago, House Bill 3215 did allow the Energy Star and RESnet HERS index to be a compliance pathway. I'm not going to go deep in the weeds here, but there's still some confusion about, well, if the city has adopted 2021, how are we going to make sure that Energy Star compliant? Because the Energy Star 3.1 has a backstop that's older than the 21. We have some cities that are pushing really hard back, saying, I don't care that you're Energy Star, you're also going to comply with 21. That adds to a lot of confusion with the building industry. It adds to complexities of just construction costs and addition of construction costs. If you have specific questions about that, by all means, put it in the chat or the Q&A, or use my contact information at the end and let's discuss it in more detail. So it always comes down to the city has final jurisdictional say. They can decide what they want to do. They can amend the code how they want. But if they've already adopted the 21 without kind of understanding the complexity of what Energy Star does and doesn't do, if you don't already have an amendment in place, it's kind of tough to enforce that. Even though, and again, won't go deep in the weeds here, but Energy Star's checklist does show that the more stringent measures should apply. And in that wording, it should mean that the 21 requirements have to apply to an Energy Star certified home. But just about all the cities that I know of in Texas that are on the 21 are allowing just an Energy Star across the board compliance pathway without adhering to a 21 updated. So with that 45L tax credit, we talked about that a second ago. Their builders are getting $2,500 back if it's a 3.1 right now. If it's going to be a long project that's going to finish after January 1st of 2025, they have to already be on 3.2 or transition to that 3.2 going forward. 3.2, we talked about it on a different website or webinar with Energy Star, but 3.2, in my opinion, added some flexibility for things that if a measure isn't met, it doesn't just automatically fail the certification. So going from 3.1 to 3.2, it does change things because the backstop moves to 21, but it also adds some flexibility to not just, oh, hey, you don't have a gasket under the garage wall, so that you fail Energy Star no matter how much money you've thrown into it. They've added some flexibility in there that can actually push the builder through and still be certified. So I like to see that. But the one thing that we did ask of the EPA and just said, hey, can you help us with this? There's confusion in Texas with the 21 and, you know, what compliance measures do we need to do? They did some analysis. They did one in Houston, one in Dallas, one in Amarillo. They did both gas and electric only. And as you can see on this, every single one of them came in below the Energy Star, the code requirements. So it actually was at the least 5% better in Amarillo, 10% better in Dallas for gas, 6% better for Dallas and for electric, and then Houston 9 and 13%. So even though they're not going full force and being enforced to do the 21 requirements like R8 ductwork and additional measures of the 21, they're still more energy efficient than a code built house, and that is the older 3.1 version. Even though the backstop is 2012, it's still showing that it's more energy efficient. We picked those three cities. They are a good representation of a dry climate and then a humid climate and then a very humid climate for climate zone 2. And so 3 different climate zones were represented there. But that gives us a good indication of, again, we can talk about this offline with city specific, but if you're in the 21 cycle already, there's really not a reason to force a builder that's doing Energy Star to go up to the 21 level yet. They're going to get there anyways with the 3.2 if they're going to continue the tax credits. So we have a very short window of how do we navigate this? We can help with that and talk to either the builders, the building officials, the plan reviewers, and we can talk through this and just say, look, I understand it's confusing, it doesn't make sense, and yes, the more stringent needs to apply, but overall what we're reaching the goal of is more energy efficient than code. And so it should just kind of be allowed to push through as a 3.1 across the board Energy Star certified home, and then just move that on into the 3.2 where the backstops equal what you're already at for code. But with all that, the HERS, the ERI, the performance, Energy Star as well, you're going to need software to do that. So prescriptive and total UA, you can use a REScheck. That's the free one that's online. There's always questions that come up to say, well, who's allowed to do that? Can it be the builder? Can it be a third party? Can it be the HVAC contractor? Again, that comes down to up to the city's interpretation and enforcement for that. It says code official has approval to who actually does this. So if the builder, and you think the builder understands building science enough to actually build an energy model, just look at that. We'll talk about what those look like in a minute and what's important to look at for the reports. That's pretty much what some of this webinar is for today. But REMrate, Ecotrope, they're a paid service. You have to do a licensing fee for that. It's much more granular. It has a lot more trade-off options for that. So most of all the national builders will go Ecotrope and REMrate because it gets them the lower and the lowest construction cost for meeting code compliance. REScheck and IC3, there's differences between the two. We'll talk about those in just a second. Some of the engines, the way they're built, it kind of, they've tweaked them both, and so there's more importance leaning towards one way or the other. So well, we'll just get right into it. It's harder to explain that way, but we'll just start out with REScheck. So for REScheck, I just put on here, what is it used for? It basically is appropriate for insulation and window trade-offs for 1 and 2 family dwellings, multifamilies that are 3 stories or less, such as apartments, condominiums. REScheck works by performing a simple U factor by the area, meaning the total UA calculation for the building assembly for the overall UA of the building. Now, nowhere on here is it talking about mechanicals because that's not being brought into that. What it's doing is looking at the building shell. The UA would result from the building conforming to the code requirements is compared against the building UA. So you're modeling it against a referenced home. So if the total heat loss represented as UA through the envelope does not exceed the total heat loss of the same conforming to the code, well, then it generates a report and it declares that the building is compliant with code. So REScheck, you could not, it doesn't allow you to do a failing report. IC3, you can look at it as a failing report and you keep tweaking it till it matches. But with REScheck, it won't let you actually print a report. REScheck supports the codes, the 2009, the 12, the 15, the 18, the 21. Same with commercial. There is a PC version, and now there's this web version, and they've updated the web version on commercial. I think it's still a year out for the web version of the REScheck to be updated to be more streamlined, like it did with the commercial and the ComCheck, like we talked about last time we had a webinar. But as you see in parentheses, the 18 and the 21 is on the web version only. So they're really going to start navigating away from a PC downloaded version. That newer REScheck is going to allow you to have a project sharing. That way, everyone that makes changes will actually be able to see it in real time with someone else making changes. But one important thing to note is this actually pulled up a notice, and I thought it was interesting to put this on here. But as it says, compliance with the 2021 IECC Energy Code can be demonstrated using the total UA alternative or performance alternative. However, Neither of these alternatives allow credit for high efficiency mechanical equipment. And then in red, electrical resistance heat cannot be modeled with the performance alternative, so the total UA alternative must be used. So if someone's going with the heat pump, that changes what actually can be used to model this. That's why I get a lot of calls from people of, hey, I'm using a gas furnace and I can't get it there. I can't get it to pass. A lot of it has to do with the fact that the way it's being modeled and what you're actually using. I said that backwards, I believe, but if you're using a heat pump, it's getting harder to actually get it to pass because the certain pathways won't use that calculation to be able to get through that. So just take note of that as well. So looking at the energy reports, this is kind of what we're going to look at, is just looking at the energy reports, kind of point out what it is that's important to this and why it is that you need to be, from the plan reviewers and the permit techs, what am I looking for to say this is right? Just as you see here, if you're looking at it and it has a big green bar at the bottom and it says passes using performance alternative, there's still things you need to be looking at specifically to say, is this actually the same house? Are they using the right energy code? Is the location correct? And then as you see orientation, it says building faces 270 degrees from north. So it's not giving an exact, it just says this is what its way from north. Looking at square footage, how closely is that correct when you're looking at the plans? Sometimes it could be off. Then it shows the glazing area, and then specifically, what climate zone are you in? So if someone's trying to do one for Dallas, which moved in the 21 from climate zones 3 to climate zone 2, are they using the correct climate zone? That's going to be, once you put location in, it's going to tell you the climate zone. But if location is off, that's a big no-no. That's right off the bat. There's a telltale sign of something's not correct. But as you see at the bottom, it's 0.4% better than code. And we'll talk about the chapter 4 stuff, but if you look at it, and in this house in specifics, I mean, I did this one and just threw numbers at it, but I'm 0.4% better than code. If that insulation is installed in the walls poorly, and I go from a grade 1 to a grade 2, this is no longer passing. Because it's that close to compliance, a poorly installed insulation is now going to fail that. We have a question in the Q&A. Let's see. I often see 2021 REScheck submittals that don't appear to show any trade-offs. Instead is allowing R30 without upgrading to other elements. I often don't accept REScheck if I don't see the actual trade-offs. Yep, that's a great point, Benjamin. That's a great point. They need to list that, and looking at that, IC3, it asks you to show what are these trade-offs as well. That's why I say there's a differences between REScheck and IC3. But if nothing else, they need to give you a supplemental letter that goes to that to show what trade-offs they're using. But as we find out historically, those that, since it's a free software, those that use the software that don't really know how to do it, they just keep throwing numbers at it until it makes sense and it has a green bar that says it's compliant. That doesn't make it right at all, because now it has to be constructed using what was determined in the projected model. And more than likely, that means they're probably not. They were just needing to get construction documents to the city for permit. They've now got the permit. They're going to move forward with however they see fit, and whatever equipment and whatever insulation, however it needs to be installed, whatever windows, and it's not fully compliant. So that's where it comes down to. There are some cities that are on iPads that have this with them as they're on site. There's other cities that don't. And so those cities that don't, they don't have this detailed data that's there that was used for permit. They don't know what they're comparing it to. They're just kind of going off memory to say, well, that R13 looks like it passes. It's Bat's wall. Let's just move forward. But that house may have been permitted with a R3 continuous outside, but they're still just using T-ply or OSB or zip board with no continuous insulation. That fails code. Just because I say it fails code, it could technically fail code because that's not the way it was permitted. Great question. Thank you. So the envelope assemblies, as we see here, it in my opinion, it's listed in a list, and I see that it's kind of looks confusing. IC3 kind of puts it in different order, which I think makes it easier to look at and read if you're not used to doing and looking at the reports. But you're just kind of comparing the gross area or perimeter This just says what's the ceiling perimeter. This isn't the house square footage. This is just what's the flat ceiling perimeter. And then you're looking at the walls and the windows and the doors. And if it's going to be listed at an R value for like insulation in the walls, but for windows and doors, you're going to see U factors. But as you see, the column says proposed U factor and then required U factor. You're looking for that to be either equal or the column on the left is going to be lower. There's not really a comparison of R value. That's where it comes down to. You just kind of have to look at, you can look at the prescriptive table and say, in my climate zone, is that meeting that requirement? But at the end of the day, if they're using a performance or a total UA trade-off, that may move the needle a little bit on insulation for ceiling. It may drop it to an R4 point or a 49, I mean a 42. If it goes to 42, where did they make those adjustments? That's what Benjamin was talking about a second ago, was they're saying 38 or they're saying 30 or they're saying 42, and you know for a fact that doesn't meet code prescriptive table, but it doesn't have to if it's a performance model or a total UA trade-off. But where did they make adjustments? Technically, like I said, historically, and I hate to say it this way, but a lot of times you'll see just whatever tweak that has to happen throughout this just to get a pass. And as you see, they show continuous insulation as R3. A lot of times we'll see that listed, but it's not installed. So they did that because they lowered the ceiling insulation. They added continuous insulation to offset, to give a total UA trade-off to pass the house, but that's not what their intention is to construct it. And that's where it comes into the city official or a third party going out and doing the verification needs to make sure, does it match the permitted documents? That's where I get a lot of calls of, I even have some cities reaching out to me saying, look, they're not giving us what they're doing. They're just showing us a letter that it's compliant. You really need to see, what is it that you're doing? Because if you're using performance, I need to know where you traded off. Because when I'm in the field doing inspections and I don't see R49 and I see 42 or I see 38, how do I know that's correct? Without looking at this detailed list, you just don't know. And then last thing, you do and can put mechanical equipment in here. Just verifying, is the AFUE, this is considered a gas furnace, but an AFUE, if it is at 80%, if it's 90% is what they installed, but they modeled it at 80, that still means that the model should be updated. It's not going to fail because that's a higher efficiency equipment, but is there something else they could have traded off to make those cost of construction lower? Air conditioning 17 SEER, I've heard a lot of times they're throwing high SEER equipment on the model, but they're not installing it because it's too expensive. As you notice here, you don't see tonnage. I've also seen where a 4-ton was supposed to be installed and they instead installed a 3-ton because they bought cheaper equipment. It's not showing it in the model. So it's something to look for closely. And as you see on this is the last page of that first report. It says additional efficiency packages, and we'll talk more about those when we get to that chapter 4, but it needs to list one of these. What did they do? Just about all pathways through the code must show an additional efficiency package unless there is a city-specific amendment where they're actually not requiring this. However, if you don't list one here, it's going to be harder to get the model to pass because the model knows it's required, even though the city has amended it out and said, we're not going to have to accept, we're not going to take that, and you don't have to do it. Then how do I get a passing model without it? That means somebody may just throw something in here to show that they did it, but they're not going to do it because the city doesn't require it. But that's the only thing getting them to pass the model. It gets very confusing. And then, of course, it does print off a 2021 IECC Energy Efficiency Certificate. This can be posted on the electrical panel. Technically, this is, in my opinion, it's one of these things where this is a preliminary, it's not a final. So really the numbers that you see here listed should be what actually was installed. If the builder does exactly what the model says, then this panel sticker and or certificate will be exactly what it's supposed to be. However, as you see, it says above grade wall R16. I don't know that they make an R16 bat. So how did you get that? So I'm looking at it and I see R15 or I see R13. This should not be just pre-labeled as a certificate. What you should see is what actually was installed by the inspector that inspected it, is verifying, signing it, and dating it that it actually is installed correctly. Same for ceiling insulation. flooring insulation, ducts. This leaves a space to say in the unconditioned spaces, what is the R value of the ducts? And then of course, window values. A lot of times the window values, I've seen this a lot is, especially when we had supply chain issues, was they projected one thing, but when they get to the warehouse or the window company comes out on site, it's a little different. It probably doesn't mean it's going to fail, but it's adjusting the consumption of energy. It could, especially if it's only 0.4% better. Just changing an SHGC or a U factor on a window could now fail the model. And then, of course, it lists the efficiencies of the equipment. And then on the water heater, it leaves blanks there so you can fill that out. So again, if you have specifics and we want to go deeper into REScheck or IC3, and I can help with the plan reviewers or the permit techs, and we can meet online and go through a Zoom call and talk about it in depth about what's important to look at it. We don't have a whole lot of time to go through and dig through every single part of that. But the IC3, this is Texas A&M's version. It's the International Code Compliance Calculator. It's a performance-based residential energy code compliance tool. I'm still surprised that there are some cities that don't really and have not really heard of the IC3. And it's rare, but it's still out there. A lot of them know who REScheck, know what REScheck is. They know that they accept REScheck. It's in their code of ordinances, but they're not really sure what IC3 is. It's a Texas-based thing that went through there. But you know, what is this? What does it mean by having a compliance tool? So it's the same as REScheck. Its one and only job is to compare the annual consumption based on the calculation that is based on the heat load in and out of the building. So you're looking at the building shell, and you're looking at heat load that comes in, and how do you condition that to offset the load coming in or out of the building, and you look at how much that annual energy consumption is and compare it to a referenced house to say, this is where it should be, this is where I'm at, am I equal to or less than, am I compliant? Its job is not to point out what's not compliant to the written words of the code. I say that with, you build the model, it either passes or fails, but I have a harder time with IC3 when I play around with it is to, okay, it's failing, but what's failing? I don't know. I just have to keep tweaking things to see if I get it to pass. And a lot of it is based on just checking a box to say that, yes, that's going to be met. Yes, that the intent is going to be met. Yes, the intent's going to be met. But that means, is it? I mean, you could checkbox it all day long. It doesn't mean it's actually going to meet that intent. And then the current codes that are supported is currently the 15, the 18, the 21, an advanced envelope, and the North Central Texas COG amended code. So REScheck doesn't have that listed in its library, but IC3 does. So if you're a North Central Texas city or any city in Texas can adopt the North Central Texas COG amended code, and you can use that, but you're going to now have to ask for an IC3 instead of a REScheck for compliant because that's in its library and has the calculations. So with that being listed, here's kind of what we're looking at. I misspelled that, sorry. It's NCT COG. It's the North Central Texas Council of Governments. It runs analysis every time a new code cycle comes out. They run an analysis. They create an amended code that still shows compliant. What they're really doing is tweaking numbers here and there. They're making it easier and better for the building industry to still be compliant with code, because all you're really looking at is what's the total consumption of energy when you're comparing it to a reference home, and am I equal to or less than? So with that, the biggest changes that you see here for climate zone 2 and 3, they did move ceiling insulation down to an R42. The fenestration U factor went up to a 0.32. The wood frame walls for climate zone 3, they took it from a continuous 5, R5 down to a 3 continuous. And then of course, slab edge insulation, majority of climate zone 3 has removed that due to, there is an exception that says if you're in a high termite area, you don't have to do it. But North Central Texas COG just amended that out and put 0. And I did also put a QR code here. If you wanted to QR code that, you can look directly at the North Central Texas COG amended code, and you can read more into that. And it may not be that you may be able to pull some things out of that that looks important for your city. If you're going through that adoption, you can just look at it and have some maybe some amendment ideas. But overall, in my opinion, it's a good way to go through an exception and get the building industry This is where you have less impact to the construction costs, is to have something like this. And as you go to their website, it will say that any city in Texas can use that. They also have forms for compliance that you can use that are editable, and then you could put your city's logo on it and actually have that on there. So this is the report from IC3. As you see, it just shows an arrow. Most of the time, this is in black and white, but it's either green or it's red. It's green going up. It says 1% above code. I've blanked out the project name, but same as the REScheck, the important part is, does it meet the county and the city? Is it in the right location? And then, of course, looking at the builder name, the project, the address. But at the bottom, as you can see, lower left, I try to talk to cities about this a lot, is if you have a sustainability manager or environment development manager that's looking at, and they're having to report to the city the CO2 output and greenhouse gas emissions. I mean, these reports gives you that in those reports. So you can use that as your metric when you estimate how much in single family has been built in your city. You can look at these reports and start adding that up and made a really good estimate and a proposal of, this is how much was saved since we've adopted the new energy code. And of course, authorized signature needs to be on there as well by who actually did the report. And as I said earlier, to me, this is a little easier to read because it goes into general and structural and windows and mechanicals, roof. It breaks it down into categories, but it's easy just to look at. But the important thing to look at is, does it have the right number of bedrooms? And then, of course, as an inspector, what's the wall cavity insulation? What's the wall continuous insulation? What's the orientation? What's the exterior made of? What's the mechanicals? With this, it shows a blower door test of 1 ACH. That's extremely tight. That's hard to even do with foam houses. So if this is how they're modeling the house, and it says wall cavity insulations R15, you don't know what type of insulation that is. Is it foam or is it bats? If it's bats, I probably can guarantee you they're not going to get to that 1 ACH. But what they're doing is they're just proposing this to say, that's my mark of what I'm really going to attempt to do. But more than likely, they're not going to get that to that threshold. But as you look at mechanicals and you move down, it says ventilation type balanced. That's an ERV or a HRV. If you don't see a big box that has 4 ducts going into it, then they're not using a balanced system. There are other ways that they can do it, other hybrid ways of doing it, but that's not common. And so you don't normally see that. What we normally see in Texas is either a supply only or an exhaust only system. The supply only is looking at a duct to the air handler, and or it's looking for an inline fan. And we'll see what those look like in a minute. But it also shows what's the ventilation rate that's coming through. If I see a 6-inch duct on the return plenum, and they're telling me they're going to pull in 222 CFM, I know from being in the field for over 10 years, that's probably not going to happen at all once I test it, which testing is now required for the 21. It will not reach that 222. There's another question here. Let's see. I'm concerned how IECC3 models the 21. Using the additional efficiency measures should not change the energy savings results. However, IECC3 is doing this. I agree. There are things in that energy model, the engine for that part of it says these additional energy efficiencies should be nothing more than a check. When done, this arrow is also in case of, yeah, we've been talking to Austin as well. It says also the arrow is for the case of the Austin 2021 IECC using IC3. But if you use a tankless water heater, because that's one of the measures you're going to hit, that reduces energy consumption. I agree some of it won't, and it should just be part of a checkbox, but it's a way to well, I won't go too far forward, but in the 24, they changed this, those things go away and it goes to a credit system, which now they get credit for things that they're doing that may not affect the overall energy consumption, but it's helping it to reduce insulation around the envelope because you're still doing something that has a measurable, well, it has an impact to the building, but the energy model can't calculate, if that makes sense. So good question for that. Great point. I don't know the right or the wrong to that, but there's always questions. That's why I'm bringing both of them in here, is because there's a difference between the two and the engines are not different. They calculate things differently. There are some things that give additional efficiency credits to, or enter the efficiency measures to, which may or may not affect it. And if it does, it may or may shouldn't be doing it. It's hard to explain that way. I do agree with that those engines are different. And then it goes into R6 ductwork. It talks about the fan power, but if you look here on the balance, the fresh air, mechanical ventilation, it says ventilation operation 6 hours. That's 6 hours a day. Fan power 0 watts. Well, if you're pulling in 222 CFM of air, then there's no way that's doing it without a power consumption. So they put 0 watts because they really don't know what it is that they're installing to do that with. And so they've put 0 watts. Again, this is not something that's going to point it out and go, you showed CFM, so you have to have power consumption. It doesn't tell them that. So they can put 0 and it just shows, hey, it's super energy efficient. It uses no power to pull in outside air. But that doesn't mean that it's correct. So that's things that you need to look at. That's red flags popping up. And then also a duct tightness test, 0. I've, in my entire career of being an energy inspector, have never seen one hit 0. So that what you're doing is projecting how much you're going to leak. It's not saying this is what was tested, but when it is tested, it should be updated in the model to say, do we still comply? But we know, and we'll talk about later, what duct tightness targets are. So it should, at the very least, they should put the target there. So what's my target? Because that's the CFM allowed by the code. And then you're going to try to hit that or be below. Just putting 0, you're falsifying it, in my opinion. It's not correct. Unless it's a ductless system, then that makes sense. But if it's not a ductless mini split and there's ducts attached to this, even the best systems out there are going to have leakage. And then, of course, supply duct insulation, return duct insulation as well. The roof, you've got square footage of insulation. It shows the cladding type. Does it have radiant barrier? Yes and no. Yes or no. If you see that it says yes, but you go out on site and it doesn't have it, radiant barrier has an impact. It can be modeled and it has an impact. Even though it doesn't have an R value, it has an impact to energy consumption. The 2024 is including it now in their code, and they're actually identifying it. They're defining it, and they're adding it in as they should have it, because it does make a difference to energy consumption and the heat that's built up in the attics that are not foam encapsulated. So you need to look at that. And it says, is it a sealed attic? No. So that's going to be ceiling insulation. Now you're looking for baffles in all the cavities. Foundation type, as we see, foundation insulation, more likely than not, it's 0. With this, it does list AC, SEER 14, tonnage 4. This actually lists the tonnage. So if you see a tonnage listed there, you're going to make sure on site, is that what it is? And then the water heater, of course, they put electric, it's 0.93. That may or may not be correct. You have to look at the energy sticker that's on the water heater once it's installed. And then looking at square footage and window area for each side of the home, just front, back, right, left. Just add those up, and does that calculate correctly on the windows that are actually installed? Those, again, you can adjust that, and it can have an effect on the energy consumption. This is its annual estimated energy use. What you're looking for is, you've got a proposed design on the left, you got a standard reference on the right. What you're looking for is the proposed being equal to or less than for the energy consumption, and it has different categories that you can look at and go, what's causing this thing to fail, or where are they really efficient? As you see, it says mechanical ventilation proposed 0. Standard reference is showing 217 kilowatts. So to me, that's a red flag. You have to have mechanical ventilation. How are they doing this without energy? That's probably not happening. So if they, as you see at the bottom, it says 85.3 compared to 85.4. If I added 217 to that mechanical ventilation, we're probably no longer compliant with the code. So what is their strategy, and how are they getting there without energy? Another project here, I won't go through all this again, but as you see, mechanicals, blower door testing at 3 ACH, that's more like it. Ventilation rates 180 for mechanical, using 8 hours a day with 12 watts. 12 watts, to my opinion, is a little bit low, but they're estimating at 12 watts. How are they doing that 12 watts? They're showing a duct tightness of 88. To me, this is a more honest approach for the report, and not just throwing numbers at it, trying to get it to pass. That's just my opinion. Again, I don't know this one for a fact, but there's still always things that hide in these into the reports. Same thing with this estimated annual energy use. We're passing. As you see, at least they put a 35 on the mechanical ventilation, and the standard reference is showing 234. They had a lot of wiggle room. They're way under on code. As we see here, compared to the standard reference, they had some wiggle room for that. So if they put a mechanical ventilation in that's using more energy, and let's say it's 180 instead of 35, they still pass because they're under that 234, but you'll have to rerun the numbers just to find out. Again, if you have questions with that specifically, we can talk about it more offline. You guys can call, we can do a Zoom call, we can talk about specifics. I won't, we don't dig into who the builder is. Just show me the report. Let's talk about what is important to look for, and that we can talk about it, what you're going to see in the field for compliance. And now the Chapter 4 key updates. We've gone through this before, but it's like I said earlier, there's a lot of cities that are now adopting this, that are reaching out to us asking questions. But this is the additional efficiency packages. It's enhanced envelope performance. And this is what the gentleman said earlier about how some of them are giving credit. IEC3 is where it probably shouldn't, but more energy efficient HVAC equipment, reduced thermal water heating, a more efficient duct thermal distribution, like putting it in conditioned space, and then improved air sealing and a more efficient ventilation, like using an ERV, not just a duct on a return plenum. So those things you can do. However, with that, it does say, and it's based on compliance path. If you're doing prescriptive, you need to pick one, and one must be installed. If you're using performance, you can pick one, or as long as your energy cost annual estimated consumption is 95% or better than the reference, then you don't have to pick one of these options. And a lot of times, as we noticed on those two that we looked at, most builders will only just barely meet the code. So to get them to that 95, they're doing more insulation, they're doing better windows, they're doing lower duct leakage, they're doing more duct insulation, they're doing lower ACH for blower door. They're doing something to get better than 95% or equal to or better than 95%. And then they don't have to pick one of those. If the builder's already using a tankless water heater, they're already there. But if they're using performance and they're still using a tanked water heater, and they just say, look, we're not going to pick one of those options because we don't want to spend the extra money, they're going to have to do that somewhere else anyways, because it has to be 95% or better than the referenced, and not pick one of those. And then, of course, ERI, they're not asking you to pick one. It just says the ERI must be 5% less better than the rated index target. So if you're looking for a 62, it's got to be 5% better than that. And then you don't have to pick one of those measures. The certificate, I always put this on my webinars that are on here, but I found one online that's actually, in my opinion, a lot better, because it adds the additional things that needs to be on here. They've expanded it for the 21 to include the addition of the code that you're on and what compliance pathway that you're using. And also now says, what are the photovoltaics? Do you have renewables? If you do, tell us what's its array capacity, what's its inverter efficiency, what's the tilt for the panels, what's the orientation, and then what's the ERI with PV and what is it without the PV. And so this can be used for an inspector to look at and go, okay, now I need to know what I'm looking for. It also says it indicates the ERI score is applicable. So if you're using ERI, what is it? But as you notice, it says additional energy efficiency, check one. And of course, it lists, I'm doing the proposed design and I'm using 95% or better than reference, or I'm 5% better than my ERI target. If not, that I'm using prescriptive, then list on here and handwrite or type in what is the additional efficiency package that they're doing. So if the inspector needs to look for a tankless water heater, then they need to go find and make sure that they've got the stubbing for that and where the framing is for a tankless water heater. Let's see, I do have a question here. It says, can you please explain more on the package requirements in detail? For the efficiencies, I can do that real quick. Let me go back to that. So good question. So enhanced envelope performance is using the total UA sum of factors times the assembly that's less than or equal to 95% better. It's an area weighted average for the SHGC. It's also 95% or better for the SHGC. That's an enhanced envelope. So better windows, better insulation. The more efficient HVAC, you're looking at heating and cooling equipment must be greater than or equal to 90 AFUE for gas furnaces and a 16 SEER AC or a 10 HSPF for heat pump and a 16 SEER AC. And then it says or greater than or equal to a 3.5 COP for ground source heat pumps. And then option number 3, reduced energy and service water heating must meet either greater than or equal to 82 EF for gas or 2.0 EF for electric or a 0.4 solar fraction for solar water heating systems, which we don't really see around here. And then option number 4, more efficient duct thermal distributions. It says must meet either 100% of the ducts and the air handler is entirely within the building's thermal envelope, or it's 100% ductless located inside the building's thermal envelope, or 100% located in the conditioned space as defined by a specific section in the code. And then the last one, measured air leakage rate, ACH, is equal to or less than 3. So if you're in a climate zone 3 or climate zone 2 that allows 5 ACH, then if you're going to choose option 5, you got to hit that 3 ACH or less. But that's also with an ERV or an HRV. And then it says with specific requirements for the efficiencies of the ERV and HRV, which the majority of them out there that I've seen meet that efficiency requirement. So that's just power draw compared to CF film that's coming in. So that's a fan efficiency for that. So hope that helped. Great question. I appreciate you asking that question. Attic eave baffles, really the only thing that changed here, and what I wanted to point out is now, even though in 2021, if you have an intermittent venting system, you have to still have eave baffles in every single cavity. Prior to 21, you just had to have it adjacent to every vent. So if you have an intermittent venting system, then you just had to have one adjacent to each vent. If it was continuous, of course, you had it in every single one, but now it doesn't matter. They all have to have it in every cavity. But as you notice in the picture, my important thing to tell a lot of them is it needs to be installed properly. It needs to be stapled to the front, pushed to the back, allowing insulation to sit over the top plate. Here it shows spray foam sealant all around it. I've never really seen anybody do that, and I don't think a city's going to call that out and say you need to do it. I think that's kind of, it may be a little bit overkill as long as it's filling the cavity. What I'm seeing is a lot of them are putting it in every cavity, but they're breaking them in half. And in my opinion, you're not meeting the intent of code. In this picture, it looks like it's a half of a baffle. Most of the time, the baffles will fully fill each cavity. If it's a 24-inch on center, it's fully filling that. If you have framing that's a little bit less, then you can break it in half. But they break it in half anyways, and they don't fully fill that cavity, which means you're still getting wind washing. If air moves through insulation, it lowers its R value. It compounds the problem. And then attic spaces, I'm really behind here. Sorry, we spent more time on that. So I'll probably just continue if that's okay. So attic access hatches and doors, insulation and retentions. So vertical doors, horizontal doors need to be insulated and weather stripped. And then, of course, what's brought into this is in the 2021 is now insulation damming, is having damming up on ceiling height changes, and then ceilings that go from over-conditioned to over-unconditioned needs to have a dam that you can fully fill that insulation to the R value required all the way to the outer edge of the top plates. That's now required as well. It can be made out of anything that's a permanent style material. My opinion is it really shouldn't be T-ply unless it's framed properly. It shouldn't be cardboard. You can use house wrap if it's framed properly. It needs to be something that's going to be permanent, not something that's going to fail over time. And as I talked about earlier, if you have just one slip in the way things are installed, it can fail code because I'm only 0.4% better than code. Now we've got insulation grading. This is where third parties come in to say, this is what we do on a daily basis. We're looking at how well the insulation is installed, how much in gaps, how much in compressions. And as you see real quick, I won't go through every single one, but even an R13 wall, 2% gaps, its effective R value is now R11. So you're reducing its effectiveness, which is not what the code needs to happen. So they're asking you to do it per manufacturer's installation instructions, which is what this is right here, directly off Owens Corning. I won't read all of it. It's kind of blurry, but it says insulation should fully fill, fit snugly within all framing cavities with no voids, no areas of compression, no gaps between insulation and framing members. That's absolute perfection, which we don't normally see in the field. And with that example we had that was 0.4% above code, if we actually used the model and we said, yeah, they're doing it per manufacturer's instructions, that's grade 1. If it's now poorly installed with voids and compressions and gaps, it's probably not passing code anymore. But you can't figure that out unless you actually run a model to figure it out. I have a question here. See, hold on. We have one here. It says, please advise cities that might want to adopt the 2024 to wait for the software updates. Yes, that's a great point, Maston. Thank you. Is when IC3 and RESchecks are updated, they have to wait for the code to come out. Once the code comes out, they start actually trying to build the new model. I know IC3 is also being updated for its reporting capabilities because Austin asked for that because there were some areas of concern with that. So they're tweaking the reports. They're also going to have to now build a referenced home with using the 24 requirements. But they can't do that until the final draft gets out, which is now out. So they're now actively working on getting it done. Maston's recommendation is it's best to probably not get that until 6 months or more after it comes out and adopted when you do the 24, because there will be probably some bugs, probably some errors that has to do with the 24 and the reporting and or the way the model is calculated for showing compliance. So great point, Maston. Thank you for that. So insulation, back to that. We'll just spin through this real quick. I know you guys, if you've been on here for a while with us doing other webinars, you've seen this, but what is grade 1? With this, you see the sheetrock on the front, top right. In the lower left, you see OSB. You've got 6-sided insulation is happening. It's got an air barrier on all 6 sides, but you see a little bit of areas of compression. So ResNet helped define this because we know that perfection doesn't happen in the field. They defined, okay, up to 2% should be allowed for minor compressions and a little bit of gaps. And if you see that, we're still calling it a grade 1. So does that meet the intention of manufacturer's instructions? We say yes, it does. As long as it meets these criteria and it meets it and looks like this. This is what I normally see in the field that is still called out as grade 1, is more than 2% of it's compressed. There's a little bit of gapping at the bottom. It is 6-sided encapsulated. There's an air barrier on all sides. So to me, we see grade 2 all day long, but we don't normally update it, and everyone just says, oh, that's still grade 1. And then grade 3, it's really bad. It's poorly installed. There's gaps missing. There's insulation missing. There's lots of compressions. If it's not 6-sided encapsulated in some places, it's automatically a grade 3. If air can get through the insulation, it's a grade 3. The 2024 is addressing the knee wall issue, but there's been arguments a lot with why does the knee wall need to be encapsulated? It's in the attic. Why can't I just put insulation on it and just point it towards the back of the unconditioned attic? 2024 now says it has to be also encapsulated with an air barrier on the backside, because what you're trying to do is stop air movement through insulation. If air is allowed to move through it, the R value plummets. So you're trying to avoid that by closing it in on all 6 sides. So as I said, thankfully, finally, the 24 is going to address the knee wall issue. Most national builders are already doing that because they've been asked to do that by the third parties. There's still the custom home builders that just don't do it. We get up in the attic, we look at it, we see insulation facing us on a vertical wall. That's automatically a big no-no that needs to be encapsulated all the way around. So I've shown this one before, but looks can be deceiving. It needs to be effective. This is just a small wall that's above the fireplace. As you see on the right and the left, it's blown wall insulation. That's grade 1 in most cases all day long because they fully fill the insulation into the cavity, and it's got the right R value to it. But over that fireplace wall, it was supposed to still meet that R15 like the rest of the house. But me looking at this, there's something that's wrong with this that just caught my eye. The framing for each stud is turned on its wide face, not on the short face, which tells me that's only 1.5 inches thick. If it's only 1.5 inches thick, how is it still R15? And so what we found out was they just tore the bats in half and put half on one side, and then they forced the labeling to be out on the other, and hoping that nobody would see it, because in their opinion, as long as it's labeled R15, then that means it is R15, which isn't true. The label's there for the manufacturer saying that's what it's been tested and rated as. If you compress it, it's no longer that. If you tear it in half, it's no longer that. If you let air move through it, it's no longer that. That's that they needed to reframe this. As you see, there's a fire block at the bottom right above that fireplace. If that was a fire block at the top of this wall, then these walls don't matter anymore and don't really have to be insulated because they're considered an in-conditioned space wall. But in this instance, it's an extension of the attic, making this an attic wall, or a wall that's adjacent to an unconditioned space, which means it must meet the insulation requirements of the rest of the house. Yes, it's a very, very small portion of the home. But this is just something, in my opinion, that builders should be looking at and going, well, that's not what I'm paying them to do. I'm not paying them to cheat these areas. I'm paying them to frame it correctly and also to insulate it correctly. So never assume the R value that's listed on there is correct until you can actually look behind it and make sure, is it cut around wires instead of just being bent around it? Because if you bend around the wires and it's crushed and there's a gap behind it, you're lowering the effective R value. And then we've gone through this one before as well, but it's the air barrier, air sealing, and insulation installation criteria table. This is what most third parties make their checklists out of. As you see, some of it's blue because if you go online to the ICCsafe.org and you look at the digital codes, anything that's new to this code cycle is in blue. So thankfully with rim joists, it now states that the air barrier must be on the exterior side. They added that. And then it also now states that rim joists being insulated must also have insulation that's permanently in contact with the exterior rim board. Instead of just being friction fitted, it has to have wire stays or staples or glue, or it's got to be foamed or something that's holding that in place permanently. And then all of this has either been reworded or changed or added. But garage separation is a big one. Energy Star is really big about garage separation. They want to have garage separation because of contamination. The code's catching up to that. Hang on, we got a question. It says, Eve baffles, can you install draft stops with a V cut instead of baffles? Great question, Moosh. And yes, I would believe so. As long as it meets the intent of moving air around the insulation, that should be considered compliant. That to me would be fine. A lot of builders that we've seen before in the past, they would just roll up insulation into a roll and they'd stuff it over the top of the top plate and say, well, we're stopping the air moving through the insulation. That to me, insulation cannot be used as an air barrier or a redirector of airflow. So yeah, anything, it just says baffles. It doesn't say it has to be a store-bought what's considered a baffle. You could even use cardboard if you needed to actually divert the air around the insulation, as long as you're meeting the intent. The code is never meant to just stop someone from having an innovative way of doing something differently, as long as the intent is met. And then garage separation, I just talked about that, but the insulated portion of the garage assembly shall be installed in accordance to a specific section. So now, even though these tables are trying to tell you what it needs to be done, they're going to also reference different sections of the book to say this is really what you need to look at to determine compliance with insulation on a garage wall. And then, of course, air sealing should be provided between garage and conditioned spaces. But this is where I always have a problem of, what does that mean? If I have a water valve box on the wall that has a hole cut in it with a metal door, is that a breach of the wall? Yes, it is. Is it air sealed to where it won't get into the house? No, it's not. So if there's a plug on that same cavity, it's going to just breathe air right into the house. Yeah, the plugs are kind of polysealed to stop airflow, but it probably isn't the best. You need garage separation, plugging up all the holes between the garage and the conditioned space. I'll get off that soapbox because that one can continue for a long time. Still, showers and tubs, we still see this as kind of an issue. Air barrier installed on the exterior walls adjacent to showers and tubs shall be separated from the shower and the tub, meaning an internal air barrier where the sheetrock would have been. Now that it's not there because the tub's installed in front of it, still needs an air barrier on the inside where the sheetrock would have been. And then it says exterior walls adjacent to showers and tubs shall be insulated. We still see a lot of times people are putting in the fiberglass drop-in tubs or shower combos. They drop them in before insulators get there, and there's no way to insulate the back of it. It's got to be pre-planned. It's got to be phased out. It's got to be phased in a section to where it's going to be insulated first before that gets dropped. So there is no problem. If it's there before insulation, they'll say, oh, we're going to get it insulated. Don't worry about it. Well, I know that's probably not true. You'll cram insulation in there, but if you crush the insulation, it's reducing its job. It should be done prior to installation. Air leakage, that's the blower door test. We talked about this before, but it's if you're using a prescriptive path, you've got different measures that you can do depending on what climate zone that you're in, what ACH. The test must be conducted at 50 pascals, which normally always is. However, there is now an exception or a different alternative way of doing this if buildings are less than 1,500 square feet. That can also be apartments. So if you have apartments of 300 apartments and you're trying to get blower door testing done, as long as they're less than 1,500 square feet of each apartment, then you can now use a 0.30 cubic feet per minute per square foot of the dwelling to calculate that instead of using ACH. Getting a building or dwelling that's smaller than 1,500 to actually pass an ACH test is going to be extremely difficult. Even when you're doing foam, it's still going to be tight. It's going to be hard to get there. So this is an allowance to say, yeah, it might calculate out with ACH of 6.5, but we're still passing because we're at 0.9 cubic feet per square foot. In the 24, that drops down to 0.27. So they're just basically kind of squeezing that orange, that lemon, just squeezing a little bit more efficiency out of that, making it a little bit harder to comply, but you're making the building a little bit tighter. So that's going to be how they're going to get additional efficiency going forward. And then the leakage rate, prescriptive path, you've got 5 ACH for climate zone 0, 1, and 2. And you've got 3 ACH, 3 through 8. And of course, with performance, it can vary. With Energy Star, it can vary. That again goes back to the reporting of the IC3 and REScheck or rim rate or ecotrope is what pathway are they using, and now what are we looking for ACH when it comes down to compliance. So if they're using prescriptive, then you better see that it says 5 or 3 depending on what climate zone. If it's performance, now it can start varying just a little bit for compliance. Electrical boxes, basically just seal your electrical boxes. Make sure the boxes are sealed, or when you're inspecting them, make sure that they're done. But I still see all the time that these plastic electrical boxes have holes all the way around it, and the only thing they're polysealing is where the wire goes. That's not what the requirement of the code says. With this, it's saying if you're using air-sealed boxes that's made to be air-sealed, it has to have an NEMA OS4 standard on it that's been tested per these requirements. Most cities strike this out and just say, as long as you air seal the boxes. But just putting poly on a wire hole isn't going to help air seal the box. It's got to be on all penetrations that are on those cheap, 5 cent, 10 cent, 12 cent boxes that are installed in the exterior wall. And then 2021 moved into all pathways and all locations of ducts need to meet this. Used to it was if you were in a crawl space, then it reduced the R value requirement. Now it says it doesn't matter where you're at. You're going to do R8 for ducts 3 inches or greater, or you're going to use R6 for 3 inches or less, unless you start using buried ducts, which we're not going to talk about here because we're not really going to see much of that here in Texas, but there's specifics to how to bury the ducts based on your climate zone and what insulation needs to go around them or on top of it. And then, of course, underground ducts utilizing thermal distribution efficiency methods shall be listed and labeled to indicate R value equivalency. I had a call earlier this week from a city asking that, if someone's burying it in the ground, can they just leave it uninsulated? There's nothing in the IMC and or the IECC that allows for an uninsulated duct outside of the conditioned space. In the ground is not part of the conditioned space. It's outside of the envelope and still should adhere to the R value requirement listed in this book. And as it says here, if it's underground, then we need to see it labeled and indicate the R value equivalency. In other words, if it's a material that's made up of I've seen plastic ones that have an R value because the thickness of them needs to have that listed, but it also in the IMC specifically states that if you can't have bare metal, it's got to be wrapped or sealed or coated in a way where it's not going to allow for corrosion or deterioration of the ducts. So there's a specifics to underground buried ducts of how you need to do it. But again, it comes out to say it doesn't allow them to not insulate the ducts. Still needs to meet that requirement. And then duct testing, it can be performed at rough-in and or post-construction, but a written report is required of the results that are tested either at post. So normally you'll get the energy form at the end for CO. It's turned in with a duct score and a blower score on there. You'll probably also see it listed on the electrical panel where the person tested it, and this is the duct score that's listed there, but it can be done either post or pre-construction. And then any test being performed at any time, if it's not an encapsulated house, which we'll talk about on the next slide, but anytime one's performed, even if it's post or pre, which this used to be different in older versions of the code, they still need to meet the same requirement of leakage, which is 0.40 CFM per 100 square feet. So for an example, an 1,800 square foot house being tested with one system, the target's 72. If you rounded that and say, well, now they have two systems. Well, if you combine those two, it has to be 72 or less. So you have one at 23, the next one's got to fill in the gap for that, and you have more allowance, but it still equals 72 or less because the target's based on the size of the conditioned space, period. And then if you're in conditioned space, used to on prior versions of the code, you did not have to duct test it because it was considered in the conditioned space. But being that even though it's in the conditioned space, the leakage is now allowing for comfort issues or high humidity issues. It's just increasing energy consumption. They now said, even if it's in the conditioned space, you're going to test it, but your leakage allowance doubles. So it goes from 4 CFM to 8 CFM per 100 square feet. So now that 72 on an 1,800 square foot house would just be times 2. It's 144 is now allowed from that. Not even, I mean, whatever, how many systems you have to do that with, the house itself needs to be that or less. And then mechanical ventilation, we've done independent webinars with this and gotten more depth with that. If you want to go look at that, it's on our YouTube channel and you can look at it. But I still get lots of calls about this. I'm out walking sites in cities that are adopted to 2021. Everybody's either, oh, I didn't know that I was supposed to do mechanical ventilation. Now, how do I do this at final? It's just an afterthought. The cities are not used to making sure it's there. It's been in the code since 2015. It's now required to be tested by a third party, but it's been in the code since 2015. They needed to have some form of mechanical ventilation. And of course, testing is now being performed. It's kind of vague on how you test it. It gives things that you can use, but there's no consistency across the board on how it's to be tested. I've also keep hearing, well, the houses we're in climate zone 2, so we're 5 ACH, so they don't need mechanical ventilation. I've read the book over and over again, front and back, and tried to find where it actually said that. There's nothing in there that says that. It says mechanical ventilation is now required. It's not based on how tight the house is. It's not based on the fact, and if someone wants to correct me if I'm wrong, but I know I've looked at the IMC, I've looked at the IRC, I've looked at the IECC. There's nothing in there that says, well, if you hit 4.5, you don't have to have it. It's just you have to have mechanical ventilation. It's not based on how tight the home is. And then all residential multifamily dwellings required to have mechanical ventilation must meet the requirement of the IMC. That's what the IECC says. And it's, of course, based on the CFM required. And we'll talk about that in just a second. But you can do exhaust only, you can do supply only, you can do balance like an ERV, an HRV, or an hybrid of both exhaust and supply, which I've seen out there from specific manufacturers have now electronically tied in the bath fans and kitchen exhaust to where when the fresh air comes on, it actually turns on a bath fan so that it equalizes the pressure inside the house. As you see, it's just got a cartoon illustration here that's just showing if I exhaust only, I'm actually depressurizing the house. If I supply only, I'm actually pressurizing the house for a brief spent of time. There can have consequences of pulling things into the wall if you exhaust only. That's why it's not a good strategy on the humid side of Texas. It's not a good strategy to use bath fans and kitchen exhaust because you're pulling unconditioned air and humidity through the walls. If you're in Amarillo or Lubbock or El Paso and you're in a drier area, you can use bath fans and exhaust. And again, I'm not going to go deep in the weeds with that, but a manual off and on switch on the wall for the homeowner to turn off and on does not meet the intent of mechanical ventilation on a bath fan. It must be autonomous. It needs to run on its own. It needs to have a switch that can be an override for maintenance and or replacement, but it should not be up to the homeowner to turn it on and have to flip it on in order to get that. It needs to be done automatically. So with that, I just pulled off the website a few that we always normally see in the field. On the left, you see a Honeywell Y8150. You also see the same version of that with April Air. They have controllers. It's a simple duct damper that's electronically off and on. So these boxes, the little boxes that you see, the square boxes, have dials in it that dials in the right calculation for ASHRAE 62.2. And then it says, okay, you're dialed in correctly. That's what you should be getting for this size house with this number of bedrooms. But it doesn't tell you that that's the CFM coming in. That's why the 2021 now requires it to be tested, is you have to verify, is it meeting the requirement? And then in the center, you see that's an April Air standalone fan box. This one's a pigtail plug-in. There's also something you can hardwire. That box can be also calculated for runtime based on square footage and number of bedrooms. Still, it doesn't tell you that that's what is coming in. You need to measure that, and then there'll be a calculation based on static pressure to say that's what the equivalent CFM is. That's what a third party's doing to test it. And then Broan makes one on the right, and then there's also one from Q-Fresh that they make as well. There's also now one from Field Controls that are out there. These things are less than 25 watts, and that's why that they've been brought out, was because 18 and beyond in the IECC 2018 and 2021, you now have penalties against using the air handler for its fan source. So just real quick on the ventilation, this is kind of where the calculation comes from. What does this house need for CFM and mechanical ventilation? It's 1 CFM per conditioned floor area and 7.5 CFM per bedrooms plus 1, or number of occupants. So that's kind of hard to always hit. So the IMC and the IRC put these tables in that said, okay, let's just go on this table and say, if you have 2,000 square feet, it's 3 bedrooms, you're going to need 60. But this is 24/7, 365 days out of the year. This is a continuous ventilation requirement for that building. If they're using a standalone fan, if they're using the air handler, 9 times out of 10, those things will not run continuously. They will be intermittent. So now you have to look at the bottom table and say, I need to estimate how often does this run to know how much CFM is actually needed to be tested. So if the same example is 60 CFM, but it only runs 50% of the time, 30 minutes out of the hour, I need to test it as a third party at or around 120 CFM when it comes on. If you're not there and you're at 85, then you're going to fail the test, which means you failed code, which means you don't comply with ventilation requirements of the building, and you don't pass the code. That's why it's important now to make sure these things are tested. It's easier to test a standalone fan because they have test ports or taps that you can read static pressure. The Y8150 and the Honeywell version and the April Air of the Honeywell version of the Y8150, you have to end up cutting into the ductwork to actually verify airflow. And HVAC contractors don't like to see that. They don't like to hear that. But that's really, unless they want to put in a test station for testing, that's the only way to verify it's compliant. And then mechanical ventilation, we said this a second ago, or I said this a second ago, but the air handler is now put in this fan efficacy table, stating that regardless of airflow on an air handler, if I'm pulling in anything, I need to hit 1.2 CFM per watt draw in order for it to meet the efficacy. And more than likely, probably 99.8% of the time, if not 100%, using an air handler to pull in fresh air is going to fail the efficacy, which means you should not be using an air handler. That's not something that can be calculated in the in the IC3 or REScheck It's not something that's going to be in there to throw up a red flag and say, oh, you failed this. It's actually asking, are you using the air handler? And then it's going to say and give you a warning when you're building the model, hey, your fan efficacy isn't hitting this, so it wouldn't allow you to pass one. But that's what you got to look at. That's why I say a lot of people put in the balanced, because that's an ERV and it's a standalone fan pulling in a lot of air with very little watt draw, meeting the efficacy, but that's not what they're going to install. Those things are costly. They're expensive. They're not going to install those. So what they're going to install is just a 6-inch duct on a return plenum, drawing that air handler as its fan source with an increased amount of CFM. I mean, a very little CFM with a full increased amount of watt draw. 2 to 3 to 400 watts to pull in 60 or 80 CFM is not going to meet the fan efficacy. Which, from a code official standpoint, if you're in the 2021, to me, it's a red flag on site. If you see a 6-inch duct with a damper attached to the return plenum, you need to know how that model was created and how they're complying with code using the air handler as a fan source. That should be something that you look at right off the bat. You could do that at pre-drywall once they drop in the mechanicals. Look for where is the inlet for that, and then what are they going to be using to actually use that as a fan source. And with that, we talk about mechanical ventilation best practices. These are actually in the IMC. Most of them are listed in the IMC, but the air intake should not be pulling from crawl spaces, attics, garages, adjacent dwellings. It needs to be at least 2 feet or more off the ground or off the roof deck. I still see a lot of the times, I say, where's your mechanical ventilation? Oh, it's right here. It's a 6-inch duct. It's going out the roof. I walk outside and look, and it's just an air hawk or a turtle box. That's not compliant to code. That's not best practices. IMC specifically says it needs to have a 2-foot stack, or it needs to come off the sidewall. So that's contamination from the shingles. Once it heats up, it's going to suck back in that contamination directly into the house. It's a big no-no for Energy Star. It's not necessarily in the IECC, but it is in the IMC, which the IECC says reference the M1505 or 1500 chapter for correct installment of mechanical ventilation. That's where it says 10 feet or more away from a contamination source, 3 inches or more away from dryer exhaust vents. And of course, inlets need to have a rodent screen on it. Some cities also have ordinances specifically against putting them over windows because they see that as an increase of flame spread. If the house is on fire and the window is opened for either someone's leaving that or it's busted out, the ambers can go right back into the inlet and actually be sucked back into the house. Now the attic is on fire instead of contained into a room. So you need to read those city ordinances to say, what's my specifics? Talk to the fire marshal. He'll probably say, I don't want those above a window. So I understand from a mechanical standpoint, it starts to get hard on where you can put these that's not going to be causing some kind of issue. But once you find that sweet spot, do that on all the houses. And that's what a lot of them do. Once you find that, it's going to be dropped into a closet somewhere and pushed out the sidewall. It'll be away from any bath fans, away from any kitchen exhaust, away from the garage door, away from the exhaust from the tankless water heater. It's always the best practices for that. And again, it's in the IMC, but not in the IECC. And then load calculations. This has been required in the code for a while. I'm still surprised of cities that don't require these at time of permit and application. It needs to be with the energy model that manual J calculations and manual S calculations have been done. It is just right size of equipment for that house based on its climate zone and based on its air changes per hour or tightness of the building and window U value and heat load through the building and insulation. All of that takes into consideration of, is this something that needs to be for the mechanical for sizing? I just found this yesterday on site. It's kind of a real easy color coded. We're mostly all in Texas in either the red or the orange. If you look at that, that means we're in zone 1 or 2. If I look at a 3-ton for both zone 1 and 2, it should be a 1,500 to 1,800 square foot per ton. So right sizing of the equipment, I mean, this is just a rule of thumb. It's not something that's always going to be this way. It's based on air tightness and load calculations of the building. I just found this online and thought it was kind of neat that they broke it down into these color codes. But Manual J says, how much heat's coming in and out of the building. In BTUs, how much heat's coming in or out of the building through windows, through doors, through insulated walls, through thermal bridging, through the attic insulation, through the infiltration, through the slabs. All of it's calculated to say in BTUs, this is what I need to condition the house. And then the manual S, they use the equipment BTU output to match the load. Both manual J and manual S. Manual J is only half the equation that doesn't really get you what you need. This is an example of the manual J load calculations. It shows BTUs. Usually they're done in block load, which is the whole building. It's not done room by room. You can sometimes get that. Energy Star sometimes asks, I think they'll ask for that in their checklist about room by room instead of just a block load. But you got the heat gain, heat losses through the building in BTUs, as we talked about earlier. Many factors make up that. So as you see on the left, it's skylights, it's windows, it's doors, it's above grade walls, partition walls, below grade walls, ceilings, passive floors, exposed floors, slabs. All of that needs to be taken into consideration to base it on how much do I need. And of course, orientation comes into play. I had someone ask just the other day, was the builder wants to give me one manual J for this one house, not depending on orientation. Well, with code, it doesn't really specify that you need more than one, but really with code in IECC, each building needs to have its own. Well, if it's always the same, you're going to keep producing the same one as long as the address is correct. But with Energy Star, it says, show me all orientations. And if it's 6 kBTUH different, then I need a new load calculation only for that one. So let's say west is the worst. Then I need one for west and then one for all the rest. So technically, if you're a city and you say what's correct, my thing is every single house needs to have a load calculation. They should not just be doing a blanket for that. But at the very minimal, it needs to match with the address, the square footage, the window coverage, the R value. All this needs to be the same. And the orientation should be listed. This is one from RightSoft. It's just a different version of the manual J. To me, I like the fact that it looks a little different. It has categories you can look at. I've still to this day seeing design conditions being changed to actually get higher and larger equipment because maybe the homeowner says that's what they want. Doesn't make it right. Here, this is Fredericksburg, Texas. They're using San Antonio's International Airport as its weather data. The design conditions for winter is 32 outside. The summer is 97. I've seen people move that to 103 or 104 or 105. And these may not be accurate. I mean, it may be 99 now for that particular location. But you need to look at what is my design conditions for that climate zone using that weather data. If you go 103, 104, you're oversizing the equipment on purpose. And as a plan reviewer, you should see that and go, this doesn't look right. I don't know of any real climate zones right now that's over 99. Everything is 99 or less for summer. And what that's doing is telling us that 99% of the time, it's going to be below that degree. Yeah, we're going to have days it's 106. That's the 1%. And you don't want to design to 1%. You want to design to the 99% for best efficiency criteria. When you get at 106, it's outside of its design parameter. The system may not keep up and the homeowner may complain that it's not conditioning properly, but it's outside of its design parameter. If you have a 3-bedroom house and they have 7 people in it, that's outside of its design parameter. They're going to have issues with comfort, but that's not the fault of the system. It's the fault of just the occupants being more than it's allowed and or able to condition based on its load calculations. And then sizing, just the important thing to take away here is that green arrow pointing in, it says 105.41% of load. That means you're meeting as close as you can to 100% of the load. I don't really know what's over the amount. If this said 145, is that too much? It's oversized. But where is the stopping point of it being too much? And then, of course, the equipment, they put manufacturer's model numbers on here. This also should be verified. Is that what's being installed? Because when you get these manual J and manual S, these are preliminaries. These are projected. This is what's supposed to happen. Doesn't mean that's actually what is going to happen. and you need to make sure, is that actually what happens? And if it is, then it meets that requirement. If they change it because the supplier was out of an outdoor condenser and they went with something else, did it change the tonnage? Did it change the SEER? Did it change the output? And is it going to meet load still? You need to verify that. And of course, lighting is now 100% high efficacy with the 2021. It was 75 for 15. It was 50% for 09. It was 18 was 90%. Now 21 is 100%. And of course, most people all just use LED everywhere, which is meeting that high efficacy lighting. But how else do you get more energy efficiency out of 100% high efficacy lighting? You put controls in. And so 2021 and beyond, we're going to see this more and more, but there's a lot of cities that will amend these out because they don't think that it's ready for that. There are exceptions, as you see, bathrooms, hallways, exterior lighting, lighting that's designed for safety and security or is exempt from controls. But like living rooms, kitchens, formal dining rooms, these things should have occupant sensors, timers, things like that will shut it off so it doesn't run as long. That's how you're squeezing more efficiency out of this. But again, I see cities that don't enforce this. I'm not going to argue the fact that they need to. I know it's something different. I know homeowners may not like it. But it's one of these things that's in the code. It's part of how we're whittling it down to be more energy efficient, is to put how often is it going to run to squeeze even a little bit more energy efficiency out of it. If you're on the 21 and you're going to look at the 24 going forward, there will be some changes that surprise you with the 24, like attic insulation going backwards. Just know the efficiency is being accounted for in other parts of the building. With increased insulation in the attic, you get to a point of diminishing return. So even adding 60 instead of 49, you're not getting any more back in energy efficiency to add more insulation. So therefore, let's get to that point of best bang for your buck and let's efficiency somewhere else, like the credit system and or other things in the code that have now changed. So in my opinion, the way the ICC has gone to their adoption and update process, it's brought more people in to have good ideas to be able to meet the demand and requirements and not just keep asking for thicker insulation. So that's all we have for today. I was right on time. I appreciate you guys being on here. This is my contact information. As I said earlier, feel free to use this and share this with anybody. I'm happy to help. I work from home. I sit here and answer phone calls and emails and schedule in-person meetings throughout Texas and Oklahoma. I'm happy to help with anything that I can. I'm going actually tomorrow to walk buildings in Tyler and to walk some houses and to look at it from the energy standpoint, because Tyler's now on the 21. So there's still some builders that have to be nudged a little bit to get to that point. But I thank you guys for your time. I appreciate it. As I said earlier, this will be uploaded to YouTube not long after this. You will get your CEU survey from Kathy Lawrence. Please fill that out and then send it back to her. Please, please, please give me ideas of what you want to see. If this is something you want to see, but you want me to go deeper into something that was in here and actually spend a whole webinar on it, please give me those ideas. I just have to come up with these ideas and make webinars out of it. What I'm asking for is what's important to you. If you want to see it, if you want more information on it, give that feedback in there and let me know what you'd like to see, and I'll build a webinar around it. So I appreciate it, guys. Have a great week and appreciate your time. I'll end the recording and I will stay on for a few more minutes if anybody wants to have further conversation. Thank you.